This video is part of a series based on the book Impact or Invisible: Surviving the Data Age with AI by Angel Reyes, available on Amazon. Welcome to video 30 in our AI.powered research series. Today we're covering a fundamental principle for responsible AI use: trust but verify. This is the protocol for ensuring AI outputs don't introduce errors into your research. Here's the uncomfortable reality. AI is remarkably capable, but also remarkably confident when it's wrong. It doesn't know what it doesn't know. It will present fabricated facts with the same polished language as accurate information. It can make calculation errors while generating perfectly formatted equations. This creates a dangerous dynamic. Researchers who trust AI too much end up with errors in their work. Researchers who trust it too little miss out on genuine benefits. The solution is a verification protocol, specific steps to check AI outputs before incorporating them into your research. Not paranoid skepticism, but systematic validation. By the end of this video, you'll have a 4-step protocol for verifying AI outputs that catches errors before they become problems. Let's understand the types of errors AI commonly makes in research contexts. Error type 1, hallucinated facts. AI generates plausible-sounding but false information. This includes fake citations, which we covered in video 21, but also invented statistics, fabricated historical claims, and fictional research findings. The AI isn't lying. It's predicting what true information would look like, but the prediction can be wrong. Error type 2, logical errors. AI can produce arguments that sound reasonable but contain logical flaws. It might affirm the consequent, confuse correlation with causation, or draw conclusions that don't follow from premises. Because the prose is fluent, these errors can be hard to spot. Error type 3, mathematical mistakes. Despite access to computational tools, AI can make arithmetic errors, apply formulas incorrectly, or miscalculate statistics. It will present wrong numbers with complete confidence. Error type 4, outdated information. AI's knowledge has a cutoff date, and even before that date, its training data may not have included the most recent developments. It might present outdated frameworks as current or miss recent paradigm shifts. Error type 5, misattributed claims. AI might correctly cite a paper but attribute claims to it that the paper doesn't actually make. This is subtler than hallucination. The source exists but doesn't say what the AI claims. Each error type requires specific verification approaches. Here's the 4-step trust but verify protocol. Step 1, logic check. Before examining any specific claims, read the AI output for logical coherence. Does the argument make sense? Does the conclusion follow from the premises? Are there unstated assumptions? This catch overall reasoning errors before you invest time in fact-checking details. Step 2, assumption verification. Identify the key assumptions underlying the AI's response. Are those assumptions valid for your context? AI often makes assumptions based on typical cases that don't apply to your specific situation. Challenge each assumption explicitly. Step 3, cross-reference. For any factual claims, statistics, or citations, verify against independent sources. Google Scholar for citations, original sources for statistics, multiple references for contested claims. Never rely on AI as your sole source for any factual matter. Step 4, domain expert review. Before incorporating AI outputs into important work, have someone with relevant expertise review it. For data analysis, have a statistician check. For legal implications, consult legal counsel. For field-specific content, ask a colleague. Expert eyes catch errors that general verification misses. Apply all 4 steps in order to AI outputs that will inform your research. Let me walk you through applying the protocol to a specific example. Suppose you ask AI to help interpret your regression results. It produces an explanation of what your coefficients mean, identifies potential confounds, and suggests additional analyses. Step 1, logic check. Read through the explanation. Does the interpretation make sense given your research design? Are the suggested confounds actually relevant to your study? Does the recommendation for additional analyses follow logically? Step 2, assumption verification. What assumptions is the AI making about your data? It might assume you have a random sample when you have convenience sampling. It might assume no multicollinearity when you haven't checked. It might assume continuous variables when some are ordinal. List each assumption and verify it against your actual study. Step 3. Cross-reference. For any statistical claims, check against textbooks or methods papers. If the AI says a coefficient interpretation means something specific, verify that's correct. If it cites threshold values or rules of thumb, confirm them. Step 4. Domain expert review. Before writing your results section based on this interpretation, have a statistician or methodologically sophisticated colleague review both your analysis and the AIS interpretation. They'll catch domain-specific issues the protocol's earlier steps might miss. This systematic approach prevents AI errors from becoming your errors. Here are specific verification techniques matched to common AI research tasks. For AI.generated literature summaries, do not just verify that the citations exist. Read the abstracts of the cited papers to confirm they actually say what the AI claims they say. The AI might cite real papers but misrepresent their findings. This is a subtle form of error that basic fact-checking misses. Take the extra step to verify not just existence but accuracy of attribution. For AI.assisted writing, read critically for unsupported claims. The AI might introduce assertions that seem plausible but are not actually established in your field. Every factual claim in your manuscript should be either your original argument based on your data or properly supported by evidence that you have personally verified. Do not let AI.generated claims slip through without scrutiny. For AI statistical suggestions, do not just accept the recommendations at face value. Check whether the suggested test is actually appropriate for your specific data structure, your sample size, and your research question. AI statistical advice is often generic rather than tailored to your particular situation. A test that is generally appropriate might be wrong for your specific circumstances. For AI.generated code, never just run it blindly. Read through the code line by line to understand what it is actually doing. Test it with simple cases where you already know what the expected output should be. Edge cases and unusual inputs often reveal errors that normal testing misses. The few minutes you spend reading and testing code can save you from serious analytical errors. Here's the impact of implementing the Trust but Verify protocol. When you systematically verify AI outputs, you get the benefits of AI assistance without the risks of AI error. You catch mistakes before they become problems. Errors discovered in your verification process never make it into your manuscripts, presentations, or submissions. They're resolved while there's still time. You develop better intuitions over time. As you practice verification, you start to notice patterns in when AI is reliable versus unreliable. Your ability to use AI productively improves. You maintain credibility. Researchers who incorporate unchecked AI outputs eventually get caught with errors. Researchers who verify systematically maintain their reputations for rigor. You use AI with appropriate trust, neither blind trust nor excessive skepticism. You know where AI helps and where it needs checking, which lets you integrate it smoothly into your workflow. And you model responsible AI use for others. Students and colleagues who see your verification practices learn that AI assistance and careful scholarship go together. Let's summarize the key takeaways from this video. First, AI is confident but not always correct. Hallucinated facts, logical errors, mathematical mistakes, outdated information, and misattributed claims are all common. Fluent prose doesn't guarantee accuracy. Second, implement the 4-step protocol. Logic check for overall coherence. Assumption verification for context fit. Cross-reference for factual accuracy. Domain expert review for specialized validation. Third, match verification to the task. Literature summaries need claim verification. Writing needs unsupported assertion checks. Statistical advice needs appropriateness validation. Code needs reading and testing. Data interpretation needs raw data comparison. Fourth, verification becomes faster with practice. What feels laborious at first becomes habitual and efficient. The time investment pays off in error prevention. Make trust, but verify your default approach to AI.assisted research. Here's your takeaway to remember. Trust AI enough to benefit from it. Verify enough to catch its mistakes. That's the balance that makes AI a genuine asset in your research. Every output that goes into your work should have passed through verification. Logic check, assumption check, cross-reference, expert review, 4 steps that protect your research integrity. The AI era belongs to researchers who can harness these tools while maintaining rigorous standards. That's what we've covered throughout this series. This concludes our Ethics and Responsible AI Use module. The book Impact or Invisible covers these topics in much greater depth, with practical templates and detailed protocols. If you found this series valuable, subscribe and hit the notification bell for future videos. Thank you for watching. This video covered just one concept from Impact or Invisible, Surviving the Data Age with AI. The full book includes comprehensive frameworks for AI-powered research, step-by-step protocols, copy-paste templates, and strategies for researchers at every career stage. Get your copy on Amazon today and transform your research workflow. Don't forget to subscribe for more videos in this series.